Great. I'm so excited to be here. This is my first time at Chitex, and it seems pretty big. So I'm very, very happy to be here. I hope you are too. So we've got about 20 minutes together, and in these 20 minutes, I'll try to give you a super quick tour of data science and cloud with some Google Cloud tools that help make the data science journey a little bit more scalable, faster, things like that. So a little bit of my introduction. I'm a staff developer advocate at Google Cloud. I work with companies and developers who are trying to utilize Google Cloud in their scenarios, their use cases. I build content for our YouTube channels and blogs and tutorials to help utilize and help make it easy to adopt those products. And then on the other side, I also work with the developer community to bring the feedback in to improve those products. So that's what that role means. Basically, I work with the community, do things like these so that we can interact, and then learn from that so that we can improve products. My Twitter handle is right there. If we don't get through all the questions today, you know where to reach me. With that, this is kind of the roadmap of what we'll go through, but we don't have to look at that right now. You'll kind of follow along as we go. So we'll start with the data science orientation. Things that you don't want to do when you're working on a data science project. I'll let you think for a second, and then here's just a small list, and there's way too many more. These are the things that you don't want to do. You don't want to provision hardware. You don't want to install software. You really don't want to worry about security patching, scaling up, down, all the things that take away the time from having you work on that data science project. What do you actually want to do? It's just solve your problem with whatever the data is and whatever answer you're trying to get from that data. So how do we get there, right? The easier and the faster way, as we all know, is cloud, so that we let the cloud deal with, or the cloud provider deal with getting things done and having you not worry about either scaling your infrastructure or getting that hardware when you need it or patching for security. All the things that you saw on the red that you really don't want to do, you can offload that, especially in a data science project. It makes so much more sense because you really don't want to spend time in overheads. You want to spend time with your data. So with that in mind, here are the 6 steps. And these steps can be, as you look at it, they can be 7, they can be 9, they can be 4. So depending on how you look at them, these are the 6 steps that I think kind of categorize the different tasks that happen in a data science project. There's data engineering, where you are collecting data from all the different sources. Especially if you work in an enterprise, the data is going to be in all sorts of different places. You'll have to bring it together in order to start making sense of it. That's where data engineering falls. And there are some more things that happen in there. We'll cover those in the next slide. Then second step is analyzing that data. Once you've brought it together, you're preparing it. Now how do you explore it? Some of the roles that fall into this category are data analysts, and the lines between some of these roles is also pretty fuzzy. You can be a data scientist and doing all of these things. You could be a data engineer and just handling the first part of the puzzle, which is bringing your data together. You could be an analyst, and you're only doing the yellow part, which is the analysis. Or you can be a machine learning engineer who's doing model development and then scaling. Or if you're in a bigger team, then model development is maybe being done by another team, and then actually utilizing that model, which comes under how do you serve that model, scale that model, make it available to be used in different applications. That comes in the machine learning engineering portion of it, which is also how you think about productionizing your models. And then the last, which is once you have all this insight, what do you do with it, is the insight activation piece. Where do you put it? What applications are going to be using it? Things like that. So those are sort of the 5 pillars or steps. And then orchestration, I've put at the very bottom because it kind of applies to all of those, because you have to make sure the data flows from one place to another, to, let's say, model development, to insights. So that whole orchestration piece of a data pipeline, MLOps pipeline, kind of falls in as a part of all of those steps. Okay, so I don't expect you to read this. This was not the intention. The intention was to kind of show that there are tools out there that help you do all of those things in different ways, depending on what you're doing, where your data is, and most of these tools are Google Cloud-based. So if you're interested, take a screenshot. I also have this on my Twitter. We can also chat at length about more on this, but we can also come back to it as we go further. So when we talk about data analytics, this is that first piece of the puzzle. You'll have to spend most of your time analyzing data, or at least getting the data together. As a part of that, let's look at data analysis first. So if you break down data analysis, it's 5-step process, right? And again, you can call it 3-step, 2-step, however you look at it. But what you're doing is you're capturing the data. That's the first step. You're getting it from somewhere. If it is, let's say, a website, you're getting the clickstream data. If it is a sensor or an IoT device, you're getting the sensor data. You're getting that data from somewhere. Or if it's just files, right, sitting somewhere, you're just bulk uploading, batch uploading those files. There is data somewhere, you're getting it ingested. That's your first step, however you do it. And there are tools for that in cloud. I've listed them there. And then the second step is you're processing that data. And by processing, what we mean by processing is you're taking that data that you ingested, and now you're either cleaning it up, taking simplest examples are like taking spaces out. I don't need this column. I need to clean the dates up, and this is the format I need for the dates. That's sort of that preparation. These are simple examples where you might be doing more, or combining 2 columns, or doing more with that. That's data processing or preparation of the data for your downstream systems. And then you store that data somewhere. Now, the way you store it, you can use 2 different things to store data. You can, and they're called differently. You can use a data lake or a data warehouse. Now, the way I distinguish between them, and I think the terms are super used interchangeably, but the way I distinguish between them is a data lake is where you dump everything. You dump all of your data, bring it in one place, and you call that a data lake, and then you can utilize or process things after. A data warehouse is where you put clean data. That's where it's already processed, and now you're ready to use that data in other downstream systems. You can pass it to machine learning systems. You can pass it to other analytics platforms where you're analyzing that data. So that's kind of how I distinguish it, but you'll find the term used differently in different places. Once that data is stored and in either a data warehouse or in a data lake, now you're ready to analyze that data, and you'll find different companies using different things to analyze data. I've put BigQuery up there because I obviously biased and love BigQuery, because you can do anything with large amounts of data using just SQL commands within BigQuery. And we'll talk a little bit more about it on all the different products that I recommend for scaling and making your data science project faster. But for now, let's keep it at the steps and how they work. Once you have analyzed this data, you have all sorts of ways to use it, right? You can put it in a machine learning system. You can pass it to an analytics system, Informatica, Looker, whatever it is that you use, you can pass it there. Now, bottom section there is, again, that thing that applies to all of those steps, which is how do you prepare the data? Where do you store metadata? Because metadata for your data, right? Because that's how you're going to do governance. That's how you're going to find and search for data where it is. And those things sort of apply to all the 5 or 6 steps that I was talking about. Now, let's address the elephant in the room, which is ML ops. We don't really end up talking about ML ops until we actually think about our machine learning model getting into production. So now we are into the ML stage from the 6-step process. We talked about data science, which was data engineering and data preparation. Now we are in the machine learning phase. Now, launching an ML model is easy. That's not the tough part, right? The operation of that ML model is the tough part. How do you put it in production? How does it scale in production? How do you keep iterating? Because the world keeps changing. The data that you trained your model on has changed the next day you deployed your model. So how do you keep it fresh? Those are the things that you have to deal with when you're dealing with a production model. When you're experimenting with just building a model, that part is super easy. So that's the real problem. How do you continuously keep that updated? The clicker's not working. There it is. Okay. Developing the model is just the beginning. I just talked about this. We'll skip through it. I think this next slide is where people get blown away. Research shows that literally 5% of the entire pipeline of machine learning and data science projects is actually building the machine learning model. Everything else takes a lot more time. And you can see how big these boxes are: serving infrastructure, configurations. This is what a ML product requires and an ML pipeline requires. You have to collect data, you have to do feature engineering, you have to create the continuous tooling to go back and update your data to keep your model fresh. So this is eye-opening, right? Because you have to not just think in the context of, I've got a machine learning model, let's put it out there. As soon as you put it out there, you have to start to deal with all of these challenges. Why do things become harder in production? I mentioned some of them, and this is obviously an incomplete list because as you do this, you'll find that you'll have more things to worry about. You have to clean the data, process that data, scale out training and also serving. So let's say your model you build a model, you put it in production, and you realized that you thought it's going to be 500 some requests maybe from an application, and it becomes so popular you've got 5 million. If you didn't think about how it will scale, that model has already tanked. So that's just an example of thinking how early on you have to start thinking about how this would scale, how a model would scale. Tracking, monitoring, and then drift and skew are super important to think about as well. So like I was saying, the world keeps changing. The data that you trained your model on has already gotten stale as soon as your model's out. How do you continue to keep bringing that feedback loop? How do you continue to take more data and keep training on additional data while the model is still in production? These are the things you need to think about. And then security controls, how do you protect that data? And these are really, as it says, incomplete list. You'll find more and more. Now, level of automation really defines your maturity. So at level 0, you've built a model and you've deployed it manually. Great work. That's good for today. Won't work tomorrow. Level 1 would be you automate your training phase. And then level 2, as you mature in your machine learning pipelines, level 2 would be you automate your training, your validation, your deployment, and also your monitoring loops. As we get to the next stage, I don't know where it works. Or do I need to? Okay. This is the paper that I was talking about that goes into detail of ML ops and the 5% research that I was I was sharing. So if you're interested in reading, this is the name of the paper. You can read through the whole thing and the life cycle of a machine learning model on any given day. Again, I think I've already talked about some of this. This is from the paper, hundreds of millions of inferences per second. Okay, so now I want to dive a little bit into how you pick when you are when you're thinking about building machine learning models. How do you pick your tools, right? Because the tools also matter. Not everybody can build machine learning models. Not everybody has the skills today to do that. Not all companies have machine learning engineers. How do they do machine learning? It's not like they can't do machine learning if they don't have machine learning engineers. So this is kind of that roadmap of how you can still start if you don't have machine learning skills. These are obviously Google Cloud tools, but you'll find every cloud has tools like this, where there are pre-packaged AI solutions, right? So if you're, let's say, working with a chatbot, you've got specific solutions for that already, which is trained with natural language processing and has some background machine learning model that already exists, and you can put your data on top of it and extend and enhance that model for your use case. So those are the best ways to start, because then you don't have to, anytime, I always say this, and I don't have this in the slide anywhere, anytime you can think of your use case and see if somebody else has a model for it, and then you can just augment on that model, that's the best way to start doing machine learning. And then the next stages here, the pre-trained APIs are, again, great ways. The normal use cases that are very common, the vision, finding things in an image, finding things in text, understanding sentiment in a natural language, in a paragraph, paraphrasing, making things shorter, speech to text, text to speech. These are very common use cases that you'll find models for that already exist. Utilize them if you're working with those use cases instead of creating a new one. And then as we move into the right section of that slide, the BigQuery tool that I was talking about, it's a data warehouse, but it comes with SQL. It's a serverless data warehouse where you can run SQL queries to query your database in a super fast fashion, because it separates compute from storage, so it can run queries extremely fast. I have some examples of that. If we don't run out of time, I will show you, but we only have 3 minutes. But that also allows you to run create machine learning models, which is why I say BigQuery ML. With SQL, you can create machine learning models with it. So if your data is already in a data warehouse like that, like BigQuery, you're already equipped, and you know SQL, so you're already equipped to build machine learning models and start experimenting from there. Once that model is built, now you can think about serving it. And for serving, you have the tools that Google Cloud offers is called Vertex AI. It's an end-to-end platform for creating machine learning models and deploying it, and it comes with all the steps that I was talking about in terms of monitoring and feedback loop of the data, how to keep it fresh, and creating a ML ops pipeline. It comes with all of that. And then it also allows you to create your own models without coding. So the Auto ML green box that you're seeing on the right, there are options to, if you are new to machine learning, you don't have machine learning skills, you can apply, they're already pre-built packages you can apply, let's say you've got a ton of images and you want to look for something in those images. And you can you can custom upload those images into the model, and it'll generate the model for you automatically. Now you can tune and tweak that model if you want, but it at least gives you a starting point. So my whole idea behind this slide is to give you the concept that you don't always, if you want to apply machine learning, you don't always have to think about building your own model. You can start from what already exists out there that fits your use case. Okay, I know we don't have much time, so I'll skip through some of these things. BigQuery is the biggest data warehouse that exists in my opinion, on the planet. You can see how fast it performs. 2 TB of data processed in 21.8 seconds, and that's working with the regex on a Wikipedia data set. So it's pretty big. So with that in mind, like you can also see if you are running machine learning models within BigQuery. These are already these are the ones that these are the models that already exist that you can utilize just with SQL queries to start analyzing your data. Most people have got the data inside BigQuery or inside some data warehouse. So if you can analyze and do machine learning and experimenting right there, nothing better than that. Cool. This is a little bit more about Vertex AI, which I've already talked about. So I'll leave you with these learning resources. If you're interested in learning more about any of the things, any of the platforms that I talked about, or just in general about this introduction, I have a blog that I've written on this in the past, and some of the architectures that are on there. There's also some labs if you're interested in hands-on stuff. That link should take you to the labs. I'll be on this for a second. BQML-use-cases. This goes through all the use cases of data science just using BigQuery. If you're interested in more learning about Google Cloud in general, this is a cheat sheet that I have created. So you can get to it just from my GitHub, so you don't have to actually copy the link, but if you just look for my GitHub, you'll find it. And that's it. Thank you. I hope you enjoyed it. I know it was a short amount of time, but if you have more questions, I think we can take them now. Yeah.
Yeah, absolutely. We have time for questions.
Go ahead.
Hey, can you hear me?
Yes.
Hi. Hey, Priyanka, nice to meet you. I actually recognized you from the YouTube videos, so glad to meet you in person. My question is, as a developer, it's pretty clear that Google Cloud gives you superpowers, but these days my clients are getting really worried about keeping data on the cloud. It's not just Google, right?
Yeah.
So I'm curious, as Google builds for the future, how do I maintain those superpowers without worrying my clients?
I think security concerns are always going to be the case. The more you can educate, I think is how it works. Like the slide that I had for BigQuery, it had at the bottom the data at rest and in transit is encrypted, and that's by default. And if you want to apply more additional encryptions on your databases and data sets, I think if you educate the clients that way, that's pretty much all. If they're concerned about where the data is located or data locality, then there are options to build projects within just specific regions. Like the data wouldn't move outside of this region if the project is inside this region, or if I create my database inside this region. So those data locality issues, and the big thing that I would mention in comparison to other clouds, when we think about government type regulations like US does, FedRAMP, and other countries have own versions of it. What Google has done is we've taken the entire infrastructure and applied that level of security on it. So it's not like a government cloud separately created. It's the same cloud that everybody else is also using that has all the certifications that a government customer would want. So I think that's pretty big and neat. Hopefully that helps. Go ahead.
Hi, Priyanka.
Hi.
I'm glad that others recognize you as well here. So I'm a big advocate of serverless computing in principle.
Yeah.
But in reality, is it possible for, of course, optimized SQL is something that everyone needs to be conscious about.
Yeah.
But is it possible to gauge how many slots a query would be using to have some sort of an idea on what's the budget that we are looking for? Because if we have 15 data engineers trying to chart out a model,
Yeah.
how do you go about that? What's your take on it?
Yeah, I think so I've worked with really big customers like that. What happens is it is really a trial and an error situation where for a few months you see how many slots are sufficient for the queries that the team is running, or if this team consumes a lot versus that team is a little different. It is, I don't have a perfect answer for this one, but it is a trial and an error process. And over time, it does become easier because you know your team's query patterns and what type of
predictable.
queries. Yeah. So it is learning curve for whatever the organization is.
I understand. Thank you, Priyanka.
Any more questions?
All right.
Great.
I think that's it. Well, thank you very much, Priyanka.
Thank you.